All right, so we're working on section 3, and all of the problems in this section are going to be unified by the fact that we are going to be replacing letters, like in this case, we replace the x with 0. So all the problems in this section are about replacing the x with a number and figuring out what you're left with. Now, this one says the function that models the height of a ball is b of x, for b for ball, equals 4 times x minus 10, where x is the time in seconds. That's important because I'm about to replace x. So this next sentence, I need to know that x is the time. What is the ball's height after 6 seconds? Well, the height of the ball is. This must be the height of the ball. It's saying the height of the ball is, so whatever this is equal to is the height of the ball. So what is the ball's height? What is this function after 6 seconds? Well, I know that x is the time in seconds. So the height here, the time in seconds, is 6 seconds. So I want to know what b of 6 is. In other words, I want to replace x with 6 seconds. Now that's the hardest part of this problem, is recognizing that this is trying to tell you, please put 6 seconds into this function, tell me what you get. What do you get? B of 6 is 4 times 6. Let me go slowly so that you can see that I'm replacing the x with the number 6. Here I go. I'm going to take this x, and when I say replace, I mean take what used to be there, get rid of it, and replace it with something new. In this case, I'm replacing it with the value of 6. What I did there is I took x away, and I replaced it with 6. So that's 24. 4 times 6 is 24 minus 10. So I'm just doing order of operations now. 4 times 6 is 24, and 24 minus 10 is 14. So the height of the ball after 6 seconds, that's what this says, the height of the ball after 6 seconds is 14, and I didn't say here, but let's go ahead and say meters. Okay, so the answer to the height of the ball after 6 seconds was 14 meters, and the function that models the height of a feather. Okay, well, now I'm dealing with a feather, and that's why it's f of x. And x is still the time in seconds, and it still wants me to know the feather's height after 6 seconds. Okay, so that's f of 6. Okay, so I'm going to take 2 times x minus 5, and I'm going to replace, in 2 times x, I'm going to replace the x with the number 6. So instead of 2 times x, it's going to be 2 times 6. 2 times 6 is 12, and 12 minus 5 is 7. Okay, now in the question, the next question on the quiz is asking you which one is higher after 6 seconds, and the answer is the ball. The ball is 14 meters and the feather is 7 meters, so after 6 seconds the ball is higher. Okay, so we're continuing in our theme of evaluating. First, I evaluated for x equals 0 to find the intercept. And then I evaluated the function b of x equals 4 times x minus 10 for 6 seconds. That is, I replaced x with 6. And now I'm going to be evaluating both x and y. It says, which of these ordered pairs is a solution to the functions negative x plus y equals negative 5 and 2 times x plus y equals 7. Now, the only thing that I really have to worry about here is the fact that I have both x and y values. So I have to be concerned that the x makes this work and the y makes this work. You can choose which one of these you think is going to be easier. This one doesn't have the coefficient, but it does have the negative. It's really up to you which one you think is going to be the easier one of these to work. So let's start evaluating the function negative x plus y equals negative 5, and we'll keep going until we find an ordered pair here that's going to be a good solution. All right, so let's try 1 for x and 1 for y. All right, so I'm going to take the x, I'm going to replace it with this number here, and this number here is x. So that's negative, instead of x, 1. Let me go real slowly this time. My function was negative x plus y equals negative 5. And in this problem, I need to evaluate. That is, I need to replace the letter with the number, and I'm going to keep going until I find something that works. Now, in this case, I'm going to replace the x with this number here. I'm going to replace the x with the first order number in the ordered pair, which was the number 1. So that's now -1 plus, and then I replace the y with this number here. Okay, so I'm going to replace the y with this number here. So this number goes here. All right, so I'm replacing y with the number 1. So x got replaced with the number 1, and y got replaced with the number 1. Okay, so -1 plus 1 is 0, and that does not work. It is not equal to -5, so I'm going to cross this possibility out. If I replace x with 1 and y with 1, I get 0, and I wanted -5, so I need to keep going. So let's use a different color here. Okay, the next one that I'm going to try out is 2, 1. That is, I'm going to replace x with 2 and y with 1. So here I go. -x plus y equals -5. What do you think? Is this going to work? So I replace the x with the number 2. And I replace the y with the number, so replace the y with one number, and I replace the x with this other number. So this is where the 2 went. 2 goes here. Okay, and then I replace the y with the number 1. Now, did that work? So -2 plus 1. Well, the 2 is 1 bigger than the 1, so that's -1 equals, no, it does not equal -5. Okay, so I can scratch this one out. That's not a possibility. All right, well, we're just plugging along here. So the next one we'll do is 4, -1. And I've got -x plus y equals -5. That's my goal. And I've got, for the x value, I'm going to be replacing that with the number 4. So 4 is going to go here. And then for the y value here in plus y, I'm going to be replacing that with the number -1. So let's go ahead and do so. I take the x and I replace it with the number 4. That gives me -4 plus, and now I take the y and I replace it with the number -1. All right. -4 plus -1, it is equal to -5. 4 negatives and 1 more negatives does in fact give me -5. So everything is looking good for this solution so far. All right, so this is a possibility. I'm pretty pleased about finding that. However, I'm not done yet because if you look, I've got 2 different equations that it has to work for. So this ordered pair can't just work for one of the equations, it has to work for both equations. So let's double check. Now the other function, so I've checked that this one works. Yes, because -4 minus 1 is -5. So, but I need to check this one. 2 times x plus y, does that equal to 7 when x is 4 and y is -1? Okay, so I'm going to replace the x right here. I replace the x with the number 4. So instead of 2 times x, it's now 2 times 4. And I'm going to replace the y, replacing the y with the number -1. Now the order of operation says multiply first, so that's 2 times 4. 2 times 4 is 8 plus -1, and 8 plus -1 is 7. Okay, so yes, if I replace the x with 4 and the y with -1, that becomes 2 times 4 plus -1, and yes, that does also work. So the ordered pair 4, -1 is a solution to both the first and the second equation. It's what I was looking for. Okay, and then we have just a brief discussion on what is a function and what is not a function. You can see here that I'm illustrating a very strange possibility. If I put x equals 5 into this function like we've been discussing, 3 times, and I replace the x with 5 minus 4. It seems like it's totally obvious that there's only one possibility. 3 times 5 is 15, and 15 minus 4 is 11. So it seems like it makes sense that there's only one possible output. F of 5 could only be equal to 11. That is true. If you are dealing with something that is a valid function. Okay, there is another possibility though. If you put 5 into the function, you can't use 3x minus 4 because it is a function. It'll always work. But if you took something and you put it into some kind of a function, you put 5 in, and sometimes you got 11 out, but then sometimes you got something different out. Sometimes you got negative 42 out. Okay, that obviously is impossible. You can't put 5 into a function like this and get two different things out. And so if that were to happen, I'd put one thing in and two different things comes out. So that's one input more than one output. Okay, so this is a bad situation. It seems obvious if I took any x that I replaced here, it seems obvious that it has to be equal to one particular thing. It can't be 3 times 5 minus 4. Sometimes it's 11 and sometimes it's negative 42. That's not the way math works. Every time we put in an input, there has to be exactly one output. So if there is one input and there's more than one output, then that is not a function. Okay, so that is a broken function. And here you can see that I've illustrated a broken function because 5 is going in and both 11 and 42, negative 42, are coming out. This is an illustration that is not a function because this one input had two different outputs. All right, and we're done with section 3, and we're moving on now to algebra, section 4.